let's jump right in. Today, we're doing something really fun in this explainer. We're literally going to track the life of a single data point. We're following it all the way through a modern, real-time data pipeline. You know, if you've ever found yourself totally bogged down by how heavy and, well, clunky traditional data architectures can be, you're going to absolutely love this. We're looking at how a platform called Estuary just effortlessly grabs change data in real time and flows it right into MotherDuck's entirely new Duck Lake and native storage. All right, let's get into it.
Making big data feel small. I mean, it's a catchy tagline, sure, but it's actually the core philosophy driving MotherDuck. For years, the industry has basically shouted at us that to handle data, we absolutely had to have these massive, highly complex distributed systems. But this is about completely eliminating that nightmare overhead of legacy data warehouses. It's taking this huge, overwhelming concept of big data and making it feel manageable, lightweight, and honestly, kind of small.
So here's our roadmap for today. We're going to look at making big data feel small, check out the real-time capture process, watch our data land in Duck Lake, test out some lightning-fast queries, weigh openness versus raw speed, and finally play around with their AI data assistant.
All right, part 1, making big data feel small.
Just think back to the painful reality of legacy data warehouses. Honestly, they're like trying to push a heavy, broken cart full of servers up a hill. They're over-engineered, and you end up spending half your day just managing the infrastructure instead of, actually analyzing your data. The modern stack approach, on the other hand, the one championed by tools like MotherDuck, it's like strapping your data to a rocket. It is incredibly lightweight, super simple, and explicitly designed to keep developers right in their flow state. No more twiddling your thumbs waiting for a distributed query to finish.
Moving on to step 2, the real-time capture.
Okay, so how does our data point actually kick off its journey? To extract it from the source system, we're using Estuary. And I want to be clear, this isn't some fragile point-to-point setup. It happens in 3 distinct steps. First up, capture connectors read the database's binary log in real time, classic change data capture, or CDC. Second, and this is the really vital part, the data isn't just shoved directly to the destination yet. It gets saved into what they call collections inside an S3 object storage bucket. Finally, materialization connectors push it to your data warehouse. That intermediate S3 step? Absolute lifesaver. If your destination suddenly goes down, you don't lose your messages or get out of sync, which, as we all know, is a massive headache with older streaming tech. And the versatility here is honestly wild. You aren't boxed into one type of source. Estuary builds their capture connectors in-house, and they can pull real-time data from operational databases like Postgres, MySQL, and Oracle. But they also hook right into SaaS tools, Salesforce, HubSpot, NetSuite. They can even extract from Snowflake if you're running reverse ETL workloads. It's a hugely flexible starting line for our little data point.
Which brings us to part 3, landing in Duck Lake.
Once our data point is captured and tucked safely into an Estuary collection, it needs a place to land, right? Enter Duck Lake. It's a new open data format built by the exact same folks behind DuckDB. But here is the brilliant innovation. Traditionally, data lakes just dump their metadata into blob storage using JSON or Avro files, which, let's face it, can be painfully slow to read. Duck Lake flips the script and puts that metadata directly into a relational database. It's a simple architectural shift, but it massively speeds up transactions and metadata reads. It makes the entire lake significantly faster and just way easier to query.
And getting your data into Duck Lake through Estuary is almost shockingly easy. Denny from Estuary had a great line during their demo. He said, "The difference between streaming and batch is really just a toggle now." And he literally meant a toggle. You just use a drop-down menu. Want real-time data? Cool. Set it to sync every 30 seconds. Want to save on compute costs when no one's working? Toggle it to sync every 4 hours. You don't have to rip up and rebuild your whole architecture just to switch between batch and streaming.
Let's jump to section 4, lightning-fast queries.
So our data has landed safely. Now, what actually happens when a developer sits down and tries to analyze it? Well, MotherDuck has this feature called Instant SQL. And I'm not exaggerating when I say it's a total game changer for the dev experience. Here's how it works. When you run your first query, say on a table with tens of thousands of rows, it's a cold query that hydrates the cache. But once that data is cached, subsequent queries are practically instantaneous. As you're typing out your SQL, MotherDuck is secretly evaluating the query in the background and giving you preview results instantly. You are literally querying at the speed of your own typing.
This ties perfectly back to that core philosophy we talked about earlier. By returning results as fast as you can type, MotherDuck makes sure you stay in flow while you're writing code.
I mean, is there anything worse than testing some complex SQL logic, hitting run, and waiting 30 seconds just to realize you missed a comma? Yeah, no thanks. Instant SQL gives you that real-time feedback so your train of thought stays totally on track.
Section 5. Openness versus raw speed.
Now, even with Instant SQL being so awesome, we still have to talk about architectural trade-offs. If Duck Lake is really that great and your data's already sitting there in your S3 bucket, why on earth would a developer ever want to write an insert into statement and move it into a native mother duck table? It is a really fantastic question, and it gets straight to the heart of modern data strategy.
It essentially comes down to what you're optimizing for. Duck Lake is built entirely on open formats, like Parquet files just sitting in your S3 buckets. It's optimized for openness and interoperability, meaning you can have Spark jobs or other external tools read that exact same data seamlessly. MotherDuck's native format makes a completely different trade-off. It is strictly optimized for mind-blowing read and write throughput and just raw query speed. Think of it like your standard medallion architecture. You might leave your raw bronze data safely in Duck Lake, but you move your heavy-hitting, highly queried gold layer analytics right into MotherDuck native tables.
And guys, the speed difference here is no joke. When you query data that's sitting in MotherDuck's native storage versus reading standard Parquet files straight from the data lake, you generally see a 5 to 10 times speed increase. 5 to 10x. For your everyday heavy analytics, that massive speed multiplier is exactly the reason you'd copy data over into the native format.
But hey, what if your data lake is absolutely massive? MotherDuck scales right up to handle that too. You've got your standard size for typical everyday queries, but they recently rolled out mega and giga sizes. A Giga instance actually gives you the hardware equivalent of a Snowflake 3 XL. So whether you're running massive aggregations, sorting petabyte-scale data, or just shoving a ton of data from your lake into your gold layer, you have the heavy-duty compute power to get it done and get it done fast.
Finally, Section 6, the AI Data Assistant. Let's look at the final layer of this incredibly modern pipeline. MotherDuck actually baked an AI assistant directly into the interface to help developers move even faster. You can generate SQL just using natural language prompts, which is cool. But the standout feature here is called Fix It. If you typo a table name or mess up some syntax, the AI instantly catches the error and suggests a fix that you can accept with just one click. And it is surprisingly smart. Like if you highlight a line of SQL and ask the AI to add a new column, it actually has the context to know, oh wait, I also need to go down and update the group by clause so this query doesn't fail. It essentially writes SQL the way a human actually writes SQL.
So we've successfully followed our single data point. We watched it go from a real-time estuary capture straight into the open Duck Lake format and finally saw it queried at the speed of thought with MotherDuck. I want to leave you with a question to chew on. How could treating streaming as a simple drop-down toggle simplify your own data pipelines today? The modern data stack is proving time and time again that big data does not have to mean big headaches. Thanks for joining me for this explainer, and we'll see you next time.